I'm Dr. Binu. In artificial intelligence and machine learning algorithms, the fifth topic in the fourth unit is rule-based classification. In rule-based classification is a fundamental technique in data science that utilizes if-then rules to categorize the data into distinct classes. These rules are derived from the inherent patterns and relationship within the data, making the classification process both transparent and interpretable. The example of rule based classification is if a customer age is greater than 30 and the income is greater than $60,000, then we can classify that particular customer is eligible for the credit and we can approve the loan. Unlike machine learning, it doesn't learn from data but relies on explicit knowledge, making it interpretable and quick to implement. The important classification algorithm is naive Bayesian classification. Naive Bayes is a machine learning classification algorithm that predicts the category of a data point using probability. It is named as naive because it assumes the presence of one feature does not affect other feature. The Bayes part of name refers to its basis in Bayes theorem. The Bayes theorem is represented as for a class C and data instant x is equal to x1 up to xn, P of C by x is equal to P of x by C into P of C divided by P of x, where P of C by x is the posterior probability of class given as attributes, P of C is equal to prior probability of class, P of x by C is equal to likelihood probability of data given class, P of x is equal to evidence, which is nothing but scaling factor, which is same for all the classes. The naive Bayesian classification is used to classify varieties of shapes, which is represented in the illustration. The assumption used for naive independence algorithm is P of x by C is equal to P of x1, x2 up to xn by C, which is approximately equal to pi of I1 P of xi by C. This means each feature contributes independently to the probability. So finally, the classifier can predict C star is equal to augmented maximum of P of C, pi of I is equal to 1 to n P of xi by C. Suppose consider the a play tennis data set. Suppose we want to classify whether a person will play tennis or not by using the condition like outlook, temperature, and humidity. Um, if the outlook is equal to sunny, then humidity is also high, means based upon that we can predict the person will play tennis or not. Types of naive Bayesian classification. Multinomial naive Bayes normally works well for text. A Bernoulli naive Bayes normally used for binary as well as Boolean features. Gaussian naive Bayes continuous data assumed to follow normal distribution. Some of the applications of naive Bayesian classifications are which is used to find the mail is spam or not, that is in order to filter the spam mails, sentiment analysis, positive versus negative reviews, document classification that is based upon the topic detection, medical diagnosis, which in which we can predict the disease. Example, spam classification. The feature words like offer, buy, free means based upon the some keywords we can classify this into spam or not spam. Advantages of naive Bayesian classification algorithm, which is very fast and efficient, works well even with a small data set, handles high dimensional data but like text or voice information, then very simple to implement. Some of the limitations are also there in naive Bayesian classification. Assumption of independence is rarely true. If probability of a feature is zero, the model is getting breaks, not suitable when features are strongly correlated. Thank you.